Hi, welcome to the final video on the straight line topic. We're going to look at finding the points of intersection between two lines. Okay, and that is it. Now, these questions are very typical exam questions, and that's what I'm going to show you. I'm going to show you two exam questions. I'm going to talk you through one fully. It may take me a wee bit of time, and then I'm going to leave you one to try by yourself. Okay, and actually, these exam questions, they'll take the same kind of, or for the most part, they take the same format. Part A is find the equation of a line, part B is find the equation of a different line, and part C is finding the coordinates of their points of intersection of these two lines. Okay, now part C is a new bit of knowledge. Part A and B, as you can see here, is stuff you already know how to do. Okay, I'm going to talk through it anyway because I do think it's quite useful. But part C is a kind of new bit of information this video deals with kind of directly. Okay, so part A, find the equation of the median BD. Okay, so this line from here to here. Okay, we know already how to find the median. The median is the key thing about the median is that it meets the opposite side at the midpoint. Okay, it meets at the middle of the opposite side. Okay, so for part A, we're looking at, firstly we need to know what point D is. Okay, so we know the midpoint is halfway between your x coordinates and then halfway between your y coordinates. Okay, so that means the point B is 3, 5. Okay, now we know this point D is 3, 5. Let's write it on. We can find the gradient of BD. Okay, so gradient of BD is 5 subtract negative 5 over 3 subtract negative 2. So that's 10, that's 5. So the gradient is 2. And from there, we can use our equation of a straight line. Y minus b is equal to mx minus a. The gradient we know is 2. A point on the line. Why don't we use d this time? Because it's both positive. So y minus 5 is equal to 2 bracket x minus 3. Take out the brackets, y minus 5 is equal to 2x minus 6. And then add 5 to both sides, y is going to be 2x minus 1. Okay, now this is actually what I talked about in a video earlier on. Okay, for equation of a straight line, I quite like to leave them as y equals, and you'll see why when we get to part C. But that is part A there, the equation of the median. Okay, part B, we're looking for the equation of the altitude AE. Okay, remember that the altitude, key point about an altitude is that it hits the opposite side at right angles. Okay, so let's look at part B. Again, we're looking for the equation of a straight line. So we know we're going to be using somewhere down here, we're going to be using y minus b is equal to mx minus a. Okay, so I need a gradient and I need a point. Okay, I already have a point, I already have a point A, so minus 112. So it's really the gradient that I want. Okay, so the gradient we're going to get, because it's at right angles to BC, if we know BC, we know AE. Okay, so the gradient of BC is negative 2 subtract negative 5 over 7 subtract negative 2. Okay, which is 3 over 9 or a third. That means the gradient of the perpendicular is going to be negative 3, since a third times negative 3 is negative 1. So the gradient is negative 3, my point is negative 112. Okay, so y subtract 12 is equal to negative 3x plus 1. So y minus 12 is equal to negative 3x minus 3. So y is equal to minus 3x plus 9. Okay, and again, there's my y equals for the equation in part B. Okay, so both that, we've dealt with that in earlier videos. Part C is where it gets interesting. This is a new bit. Find the coordinates of the point of intersection of BD and AE. Okay, so let's just remind ourselves. BD, I think, was y equals 2x minus 1. Yep. BD was y equals 2x minus 1. AE was the point, not the point, sorry, the equation y equals negative 3x plus 9. And we want to find that point of intersection. Okay, now again, actually it's a bit of revision of National Flag. It's a bit of National Flag that kind of often gets skipped over. But If you want to find the point of intersection between anything, between any two lines, between a line and a curve, between two curves, between even a circle and a line, you need to use simultaneous equations. You want to know that point where they both meet, where they both exist. Okay, so what we're going to do is we're going to use simultaneous equations. Now, simultaneous equations, oftentimes in National 5, you do it by the elimination method. You line them up on top of each other, you cancel either the x's or the y's, you get rid of them. Okay, but I'm a big believer in higher, I'm a big believer in general actually, that if you can get them both equal to y, the substitution one's much, much easier. Okay, because these are both equal to y, they have to be equal to each other. Okay, and then it creates a nice, easy equation that we can solve. Add 3x to both sides, add 1 to both sides. That's going to be 5x equals 10, so x is 2. We're looking for the point of intersection. We now know that x is 2. We substitute that back into one of our starting equations. So y equals 2x minus 1. When x is 2, y is 2 2's minus 1, which is 3. Okay, and then just finish off with your statement. So your point of intersection is 2, 3. Okay, and that is what you're going to do every time. The numbers may get more tricky. You may be dealing with fractions and whatever, but you can do that. You're good enough to do that. Okay, but part A and B will just be revision. Part C, finding point of intersection, we do simultaneous equations. I think the nicest way to do it is get them both equal to y and then make them equal to each other. Okay, now that is a past paper question, 2006 paper 1 question 1. It's a very typical past paper question. There's another past paper question. Pause it, give it a try, take it into your teacher, get it into market. I'm not going to go over it now just because I don't want the video to be 12 minutes long or whatever. Yes, any questions, give us a shout. Cheers.